Hello, geometers and general seekers of truth. Welcome to the video lesson on angles within a triangle. So, in the previous work, we've done examples with angles with parallel lines and such, and now we'll deal with specific cases of angles inside a triangle. But before we tackle those particular problems, let's just start with our little warm-up here. We know that that line G and line F are parallel, so I'm just going to put these parallel symbols here. And we know some information here about the angles, and we're asked to find the measure of angle CAB, so I'll call this X, and the measure of angle CBA, and I'll call this Y. Alright, so we're basically solving for X and Y given some information here. Well, whenever we're chasing angles, and that's what this process really is called, we're given some information and asked to find angles. So when we're chasing angles, we want to use some basic skills and strategies, one of which is vertical angles. So looking at this section up here, this angle here, this 50 degrees, is vertical to the one on the other side of it. So this angle must be 50 degrees. Okay. And if you notice, these three angles, 1, 2, and 3, the ones where I just put the three dots, they form a straight angle. So this is not a linear pair, it's like a linear triple, but the idea is the same, that these three angles add up to 180 degrees. So that means this angle here must be 180 minus 50 minus 55. And working out all that arithmetic, that gives us 75 degrees for that angle up there. Okay. And we can do some more work. This one here is 55, and this over here is vertical angles with the 75 degrees. So that's also 75 degrees. Now, to make the leap from this vertex up here to one of these two down here, we have to use some of the theorems regarding parallel lines. We have to use this given here. Alright, it's a good rule of thumb that when something is given in a geometry problem, usually, not always, but usually, you're going to need to use that given. So, if you notice, this angle up here, that's 50 degrees, and angle CBA, this one down here, they form what's called alternate interior angles. So let me use my ruler just to highlight this point that I'm making here. You have this blue line there as the transversal. Well, I've done a terrible job of drawing it. Let me see if I can correct that a little bit. So I'm going to darken that. Blue line right there is a transversal. So this one and this one up, these two angles here, they're alternate interior angles. So that tells me that angle Y, or the value of Y, must be equal to 50 degrees, okay, because we're using alternate interior angles theorem. All right. And similarly, on the other side of it, if we were to use this line AC as the transversal, you can see here that this angle up here, and I'll use two arcs this time, and angle CAB are also alternate interior angles. So X must be equal to 75, really for the same reason, alternate interior angles. All right. So there you have it. We've answered both of these questions. We know what this angle is, and we know what this other angle is as well. And this is a very brief warm-up to the real lesson of the day, which is the triangle sum theorem. Now, I know that some of you will say 55 degrees plus 50 degrees should be equal to, that these three angles in here should add up to 180 degrees, and it seems that it does, and that's a very common fact, but we haven't proven that yet. So I wanted to solve this problem using only the knowledge that we had accumulated so far. So thank you for watching. Make sure you see the next videos, and have a wonderful day.